Okay. If I mess up, you can just jump in. Welcome to this XC session, A22 on cognition. The XC week is almost over. Thank you very much for joining. It's always difficult to join the last sessions. Now you can lay on the couch and listen to the talks. We have actually 5 very interesting talks in this session. The first one is going to be given by Daniela Girardi from University of Bari, and it's on recognizing developers' emotion while programming. So Daniela, please join us, activate your camera and share your screen and go ahead.
Hi everyone, I'm Daniela Girardi, a PhD student from University of Bari, and in this talk I'm presenting the study Recognizing Developers' Emotions While Programming that I've conducted under the supervision of my tutor, Nicole Novielli and Filippo Nannubile, and in collaboration with Davide Fucci from BTH University. So emotion detection in the field of software engineering is beneficial for 3 different stakeholders that are the developer, the team, and the organization. Indeed, the developer can undertake some specific action in order to regulate his own behavior, like, for example, take a break when he's stuck or ask for peer collaboration, and this will result in an improvement of his personal well-being as well as of his individual performance. As regards the team, emotion awareness can be used to improve empathy between team members and also to enrich retrospective meetings where developers can discuss about what went well and what went wrong, also considering the emotional feedback. And this also will result in an improvement of the group performance. As regards the organization, emotion awareness can be used to take some decision regarding, for example, the job rotation if a developer is not working well in a certain team, or related to the introduction of some incentives, so with the goal of increased job satisfaction and reducing turnover. So during our study, we investigated three main research questions. So first of all, we tried to identify which emotions developers experience during a programming task and whether they correlate with the perceived progress. Secondly, we tried to identify the triggers for developers' positive and negative emotions, as well as the strategies that developers implement to deal with the negative emotions. Finally, we tried to identify the minimal set of non-invasive biometric sensors in order to recognizing developers' emotions. When we talk about emotions, we refer to the Russell circumplex model of affect that categorizes them through 2 different dimensions that are the valence on the horizontal axis, that is the pleasantness of the stimuli, so it goes from unpleasant to pleasant, and the arousal, that is the level of emotional activation, and it goes from fatigued or calm to tense and excited. The study of emotion in the field of software engineering is quite new. There are 2 studies that are well known in this domain, and are the study by Daniel Graziotin and the study by Müller and Fritz. In both the studies, participants had to solve a programming task during which they were interrupted in order to self-report the emotions they were experiencing. The study by Müller and Fritz represents also a first attempt to recognize emotions through non-invasive biometric sensor. And both the studies highlight the importance and the impact that emotion have on developers' productivity. So during our study, we replicate the experimental protocol of the studies just mentioned. So we asked the participant to solve a programming task, during which the participant wore 2 biometric sensors that are the BrainLink headset that captures the electrical activity of the brain, and Empatica E4 wristband that captures skin and heart activity. Before starting with the development task, we ask to participants to watch some elicitation video with an associated level of valence and arousal, and this was in order to get them acquainted with the tool for self-monitoring. Then the participants watched a neutral video with the goal of capturing a physiological baseline, as well as to relax them before starting the task. The task consists in using some API of text exchange and had a duration of 30 minutes, during which they were interrupted every 5 minutes with the goal of reporting emotion. For ethical reason, at the end, they watch again a neutral video, and before going home, I interview them, asking during the development of their project which are the triggers for positive and negative emotions. As regards self-report, we use the self-assessment mannequin that is widely used also in the field of affective computing. So in the first row, you can see the valence dimension. On the second row, you can see the arousal dimension. And we also ask to rate their perceived progress on a Likert scale of a 5 point from completely stuck to in flow. Totally, we involved 23 participants. They were mostly undergraduate students from our for the software engineering course of our university, but we also involved some graduate students and one PhD student. So as regard the first research questions related to the correlation between emotions and progress, we used the linear mixed model as tool for study the correlation, and we found that the valence correlates with perceived progress. This is in line also with the results of the previous study by Graziotin and Mueller and Fritz. We didn't find any correlation between emotions and arousal, and this is also in line with the previous study because Graziotin didn't find the correlation, while Mueller and Fritz found a correlation, but it was very, very weak. As regards the second research questions related to the triggers for developers' emotion, we applied selective coding on the answers that participants gave during the final interview. And we found that the developers experience positive emotions, especially when they start a new project, because it's a sort of feeling of new challenge. And also when they succeed in implementing a solution, because it means that they can move to the next step. Developers experience a negative emotion when they are stuck on some piece of code or when they feel the pressure of the deadlines. And as regards strategies, we know that developers usually take break or ask for peers collaboration. As regards the minimal set of non-invasive biometric sensors, so first of all, we built our dataset. Mostly students didn't solve the task, so this is why we have a prevalence of a negative valence and higher arousal. We use the self-report as a ground truth. And after building our dataset, we use the classical machine learning approach with preprocessing, feature extraction, and classification steps. So for both valence and arousal, we found that the contribution of the headset is negligible that just using Empatica, we can achieve the 71% of accuracy. So this is also in line with the findings by Mueller and Fritz that classify only the valence dimension. And this is a very important result because has a lot of implication both for researcher and for practitioner. Indeed, as regard researcher, we call for in vivo research with the goal of study emotion during the entire working day. So for example, in software development companies. And as regard practitioner, we believe that self-monitoring emotions during the time can be used as a alarm bell for preventing burnout. And also the emotional feedback can be used to improve retrospective meetings where developers can share their emotion not based only on their memories, but on a more objective measurement. So that's all. I conclude my presentation. I hope you enjoy it, and I'm here for your questions.
Yeah, thank you very, very much, Daniela. This is great. This was a very good presentation. So, and thank you for being on time. So I'm while watching or waiting for the questions in Clouder. Maybe I can start with one question. So I just was wondering about the takeaways or the implications. So have you thought about the how concrete application? I mean, you're saying yeah, for instance, you could warn that there is a risk for burnout. So how is this going to be working? I mean, there is an alarm, or can you
Yeah,
share your thoughts?
the idea is to develop a sort kind of app that detect that when you experience negative emotion can suggest you, for example, to undertake action like take a break or something else in order to don't continue in this negative mood. So in order to stay in a good well-being again.
Okay. I have a question here from from Clouder. Do you expect the results to generalize to collaborative software engineering activities like code review or pair programming?
Yeah, I think that these results can be used for whatever, I think. And also, yeah, because the important thing is the idea is to monitoring software developers during all their activities and during all their working day. So I believe that using just a wristband can be very important and can be very helpful to
Mm,
monitor emotions also in a work environment context. So
I
yes.
see. Okay. We have some more time to for questions. So while also maybe waiting. Oh, we have here one. Um, how many of the participants were women? If is there any difference by gender? So that's a very interesting question regarding to the your sampling basically.
Participants were mostly male students because they were students of our software engineering course, and we have only 3 or 4 women, so we didn't study the difference between the gender because the data set was very unbalanced, so we can't.
Okay. So this is something to take into account in case people perhaps would like to follow up or to. I think this is a very important point that yeah. So many of the studies we are doing, perhaps they don't consider these important aspects, like for instance participating. Of course, it's difficult. I understand, but it's I think it's an important point. So thank you very very much. I think this was very clear. And yeah, now we can move to the next talk. Which is on neurological divide. This is an fMRI study, and the next speaker is going to be Yu Huang from Michigan. And I think, yeah, she's already with us with the camera. So, Yu, if you can share your slide, you already do have done it. This is great. So, the floor is yours, and yeah, you can start.
Great. Hi, everyone. Thank you for attending my talk virtually. In this paper, we are trying to figure out the relationship between code writing and prose writing using medical imaging like fMRI. So it is a collaboration among Michigan, Georgia Tech, and UC Santa Barbara. So in this virtual setup, it might be hard to see my collaborators. So first of all, I would like to thank our awesome undergraduate researchers, Ryan and Xinyu, our longtime psychology collaborator, Dr. Tyler Santander, our research fellow, Dr. Kevin Leach, and my advisor, Professor Wes Weimer. So some of the co-authors are also available in the chat channel during this talk. My name is Yu Huang. I'm a PhD student at Michigan. My research is on the intersection of software engineering and human factors. So this year, both Dr. Leach and I are going on the job market, and he's working on software engineering and security. In 1982, this very well-known computer scientist, Dijkstra, expressed his opinion on what makes a good programmer. A very good mastery of one's native tongue is the most vital asset of a competent programmer. Well, he was probably right since software engineering involves a lot of communication. However, readers may take it in a different way and become really concerned. So, for example, you will find a post asking about this claim, and the people that are really desperate to know how to become a good software developer if they are not good at natural languages. Guess what makes them feel even more hopeless? That's when you see an answer claiming that if you cannot write well, you cannot program well. This post has been there for almost 10 years and then thousands of people viewed it. But is this a folk wisdom true? Do human beings really know the answer? Well, not really. So the good news is, in recent years, software engineering researchers have started using objective measures, such as medical imaging like fMRI, to study cognitive processes of computational activities and their relationship with natural languages. For example, there are many papers on the neurological processes of prose reading, code reading, as well as prose writing. Researchers have even used the findings in these cognitive processes to intervene and improve certain human abilities, such as treating dyslexia, enhancing memorization and code comprehension. However, we have no grounded results on code writing on the neurological level to help with it. Thus, the high-level question we try to answer in this paper is, are code writing, prose writing similar neural activities? Informally, is being good at writing associated with being a good software developer? In the rest of the talk, we'll discuss the challenges of the study, our experimental design, results, and conclusions. Well, there are reasons why code writing has rarely been explored in neurological studies. First, we have physical challenges. Because of the strong magnetic interference in medical imaging machines like fMRI, basically all kinds of keyboards programmers are familiar with will not work. So we employed an fMRI-safe bespoke QWERTY keyboard by completely separating the control logic from the keyboard itself, so the interference will not affect the signal transportation. And our participants, they can just lie down in an fMRI machine like this and do touch typing. The second challenge is imaging studies require carefully controlled experiments, and no high-level design for code writing has been proposed before. We solved this problem by designing a 2x2 contrast experiment in which we include both code writing and prose writing, as well as two types of writing tasks, fill in the blank and a long response. In fill in the blank tasks, we call it FITB just for short. You need to come up with a word or a line of code to make the entire sentence or function work. In LR tasks, the long response ones, you need to write a short essay or a function from scratch. So the idea behind this is FITB, fill in the blank, is more like a low-level writing task. And LR are more like high-level tasks that are made of the repeated low-level tasks. We hypothesize that examining FITB tasks helps us understand the low-level basis for code writing, while examining the LR tasks may show aspects of a high-level creativity of software engineering. We selected those coding problems from the Turing's Craft website, which provides fundamental coding tasks, and we selected prose writing problems from SAT. So in this study, we recruited 30 participants, 20 a male, 10 a female. The population also includes both undergraduate and graduate students. Every participant in this study undertook 52 tasks in total, including all 4 types of tasks we introduced before, while having a brain scan in fMRI. When we analyze medical imaging data, we are really talking about over 1 million brain voxels. So we need to pay extra attention to false positives. So I will not talk too much here, but more details can be found in our paper. We follow the best practice in psychology and neuroscience in our data analysis. So there are 3 steps in total. Step number 1 is pre-processing to correct things like a systematic source of noise. Step number 2 is a first-level analysis to study brain activities within individuals. Step 3 is a contrast and group-level analysis. For example, we subtract one task from the other to cancel out effects from the environment. We applied false discovery rate correction to avoid spurious correlations. Finally, we present our findings regarding 4 research questions. We'll talk about them one by one. Question number 1. Do self-report claim code writing is like a prose writing? Well, it turned out 38.5% of our participants believe they are very similar tasks. Well, the question for us is, do the medical imaging findings agree with this or not? Let's take a look at question number 2 then. From the brain activities, we found there are significant and a widely distributed difference in neural activity between code and prose writing. Actually, these distinctions can be observed in more than 10 brain regions, as shown in the highlighted areas in the figure here. So these hotter areas drive the distinction between code and prose writing. In RQ3 and RQ4, we want to understand what low-level and high-level features explain code and prose writing. We found out on the low level, code writing requires more in parts of the brain associated with top-down control, planning, and categorization. On the high level, prose writing requires more in kinetical brain regions that are associated with language processing, while code writing involves more in attention, memory, planning, and spatial ability. So this finding was surprising to us because no matter from human intuition, so just like that comment for Dijkstra's claim, or the similarities between reading tasks reported in previous studies, we thought that code writing, prose writing should be very similar, but they are really not at the neurological level. In summary, we present the first study of code writing using fMRI by deploying a bespoke fMRI-safe QWERTY keyboard. We designed a 2x2 controlled contrast-based experiment. Our main result found out that code writing and prose writing have very distinct mechanisms. So this is surprising to us. At a more granular level, in both low-level and high-level tasks, we found out code and prose writing involves more of different brain regions, especially in high-level tasks. Code writing involves more of the right hemisphere, while prose writing involves more of the left hemisphere. We hope these findings can help guide computer science pedagogy, workforce retraining, and more importantly, we want to encourage more diverse participation in programming. So now we know that even if you're not good at writing, there's still a pretty good chance that you can be a good programmer. Yeah, thank you everyone. I'm happy to take any questions.
Great. Thank you very, very much. This was on time. This was very good. Yeah, now, by the way, Yu is not only writing good paper, but she's now on the job market. So you might want to talk to her.
Thank you.
So now we have time for a few questions. I see here we have a few already on Clouder. So is there a precedent for long response tasks in fMRI studies, which typically limit tasks to 30 to 60 seconds due to bald saturation?
Yeah, exactly. That's a great point. This question, what it mentions is absolutely right. For fMRI studies, especially block design, usually we don't want a task to exceed more than 60 seconds. That's why in this uh, experimental design, we have to choose those, reasonable tasks for the participants. Before this experiment, we did a pilot study. So we only picked up those long response questions that is doable for human beings to finish in 60 seconds. Great question. Yeah.
Yeah, so I can tell that this is quite complex, the design of such studies. So that's quite interesting. We have another question here. Programmers needs to hold many concepts in their mind. What if you compared function writing versus more complex programming tasks?
Function writing was more complex writing. Yeah, so this question is kind of relevant to the previous questions. It's exactly right. In this kind of fMRI study, if we can include very complex writing, that would be perfect. But because the constraint, we can only check sort of in, relatively simple writing tasks. Just from this study, I cannot draw any direct conclusion to compare between a functional writing and a complex program writing. But I will imagine because the tasks we chose is pretty representative of code writing, either short or long, I would imagine the findings that it will indicate how programs think in complex program writing. Yeah, but that's definitely a threat to validity. Yep.
Yeah, great. Wow, I see we have many questions.
I'll be
It's really hard.
available after the talk. Yeah.
Yeah, that's what I wanted to say. And since they are all now at least ranked equally, I would like maybe to ask one more final question.
Sure.
I mean, probably you have thought about a follow up study. I mean, what's the next thing that we would like to check based on your finding?
Oh, love this question. Yes. So I didn't have time to mention in the presentation that in this study, we're just to limit the number of variables we want to check. So we can only recruit native English speakers. But one of the future study we're very interested in is what will happen if your natural language, your mother tongue is not English. What if you're bilingual speakers? Those are very interesting things we want to check. The other thing is, gender difference, of course, to different groups.
Okay, cool. Thank you very, very much for the presentation and the discussion. For those who asked questions and we could not take them now, please follow up on Slack or on a Clouder. There is the opportunity, of course, to do this. So thank you again, Yu. And now we can take the next presentation, which is going to be on assessing practitioners' beliefs. This very interesting SIPE talk, which is going to be by Srikan NC from North Carolina. So if you could activate your camera so we can see you, and then share. You already share. You're sharing your screen, and yeah, the floor is yours, and you can start whenever you're ready.
Are you able to see me and hear me?
Yes, great.
Cool. Okay. Good morning, good evening, and good afternoon to all the software engineering audience around the globe. I'm Srikanth, along with Dr. Menzies from NC State University. Today, we are going to talk about the disconnect between practitioner beliefs and empirical evidence. Okay, let's consider a few beliefs. The longer a bug remains in the system, the exponentially more costly it becomes to fix. Lessons learned from a few past projects are general to all future projects. Many go-to statements in source code induce more defects. These are very intuitive to believe, but recently software engineering researchers did not find any clear evidence for them. So that's our motivation to study practitioner beliefs, especially prevalent beliefs. But we cannot cover all the software engineering beliefs in one article, so we focused on software quality, specifically defect prediction beliefs. Because defects are not cheap, and we want to defect prediction is when you want to predict chaos in your team before it happens. It is basically to locate defects in maybe modules or your commits or your files, etc. In those lines, we chose 10 prevalent defect prediction beliefs from a recent qualitative study by Van and others from a TSC article in 2018. Belief one is a file with a complex code change process tends to be buggy. That has like 76% practitioner agreement. What it means is that practitioners trust this belief more that it would predict defects than belief 10, which is files with fewer lines contributed by their owners who contribute most changes being bug prone. Recently in ICSI 2016, Devenbo and others have done a similar experiment, and interestingly, they found beliefs varied within the same organization. We sort of want to extend that, and we want to understand, okay, there exists a disconnect, but why is there a disconnect? So to answer that specific central question, we broadly ask two research questions, which are what beliefs are strongly supported in the data, first of all, among the 10 beliefs that we chose. Then we want to look at, does the same evidence appear everywhere? Is the belief, is it true all the time among projects, within releases and stuff? So our method to do this was, we take the 10 beliefs that we want to assess, we gathered some 37 active long-running GitHub projects. Then we actually correlate between the belief metric and with the defect proneness in the post-release period. And we based on the strength of the correlation, we want to answer those research questions that we ask. So, but to model all these beliefs on a similar scale, that is an apple-to-apple comparison, without deviating much from literature was a challenging part. Whenever we felt we need to make more assumptions in modeling these beliefs, we actually discarded them, in fact, because there were more than 10 beliefs, obviously, in software defect prediction. So our approach is pretty simple, which is you assume that you have a project with R number of releases, and you want to predict defects caused by the files that changed in, say, release number 6 or commits in the modern era. And then you want to measure the belief metric on release 6, and you want to correlate between the post-release defects after the release. That's our central approach. Let me explain it with an example. Let's take the simpler belief, belief number 2. Files changed by more developers are more buggy. So for instance, say in release 6, foo.java, bar.java, and scott.java are changed by 3, 5, and 10 developers. And correspondingly, those files defects were fixed, let's say 1, 4, and 7. So when you correlate between 3, 5, 10, and 1, 4, 7, you get a very high correlation. And such a result would support this belief. So due to time restrictions, I can't explain all the modeling of the remaining 9 beliefs. So I'm jumping into the result. So the result is that, so surprisingly, belief number 10, which was least believed, had strong support. Whereas belief 1 and 4, which were having more than 50% practitioner agreement, did not show strong support. We'll talk more about this in the following slides. So to answer in a nutshell, large commits and ownership-based belief were strongly supported in the data. But to answer the second question, we divided into 3 sub-questions. One of them is, do projects show evidence for all beliefs? So let's say you're a practitioner working on a set of projects. You have some beliefs that this is what causes defects. Then you move on to a different project. Maybe a belief may not hold true in those projects. So similarly, among the 37 projects, only 24% of the project shows support for all the beliefs. So your personal experience can let you down if you are a subject matter expert. The next thing that we want to talk about is, do beliefs remain stable within the project, that is within releases? So what we did is, we divided the releases of a project into, say, large, medium, and small based on the number of files changed. And even in those, we find discrepancies. Like, for example, take a look at belief 4, which is not strong in large releases, but it is helpful in smaller releases. The last question in 2 is, do beliefs evolve as a project matures? What it means is that during the start of a project, you have a belief that you want to employ to predict defects. But over time, say after a project matures after 6 years, the same belief may let you down. So what our research shows is that beliefs tend to decay then grow. So it's not that the beliefs are going to get stronger, and it's probably also because projects tend to get stable after a particular period of time, right? So in summary, what we want to say is that only 2 out of 10 beliefs that had strong support, one that is based on large commits, the other based on ownership. So basically, the disconnect is caused by the sporadicity of the support prevalence, especially factors like project maturity, release size help explore those sporadicity. So if you are a project manager, Monday is approaching, and what we want to say to you is that do not assume effects always hold. Always set policies based on strong effects. See what works for your organization. Always monitor and adjust your code review and code refactoring process accordingly so that you can better plan your software quality assurance. Thank you.
All right. Thank you very much. We also have here quite a number of questions. So let's start. Could you please tell us which was your source to obtain the list of these 10 beliefs?
Yeah, so the source was from, as I said, from a TSC 2018 article by Van and others. It's a qualitative study. Yeah.
Okay, so it's basically referred in the paper. Probably it's a
Yeah.
previous
Yes.
work. All right. Someone is also about asking about the data you have used for your for checking basically these beliefs. Can you just elaborate? Are these open source? Just a little bit about this.
Sure. So The data is basically 37 open source projects that actually we have linked in the paper. You can use them. So what we did is we've mined manually all the comments using GitHub APIs, and we've split each comments, looked at files, how many lines are added, how many lines are deleted. We looked at bug fixing comments and all those things actually.
Great, thanks. Next question is, what's the, this is changing very quickly. What's the effect of changing computing tools, so tools basically on this? So like using new programming language, new tools, is there any effect about this on this? Your work? Do you
No,
think?
it would be interesting to explore that space, but we think these are mostly this paper is at least does not talk about programming languages and beliefs.
Yeah.
But
Perhaps one final question. So it's about somebody is calling this fake belief. Maybe I instead of this, or you can generalize this a little bit. So what you I mean, what do you think the source of where do these beliefs come from, and you know how
so all these beliefs are actually decades old defect prediction beliefs that which practitioners tend to believe in code review process. They so these are actually all these beliefs were true in the past. It's not that these beliefs are not true. And this is what this paper is. The central point of this paper is you need to always retest. You need to revisit old beliefs. You can't keep continuing something if you want to make good theories in software engineering.
Great, thank you very much. I think this was a very good closing statement. Thanks again for the presentation and for keeping on time. And now we can move with the next presentation. So the next presentation is again a technical paper. This is actually a distinguished paper. And here we go again, why it is difficult for developer to learn from another programming language. So we have Nishal Shrita from North Carolina University, who is with us. I see him already here and his slides, so the floor is yours.
Thank you, Waleed. Hi, everyone. I'm Nishchal. I'm a PhD student at NC State University, and I'm really excited to talk to you about our paper. Here we go again. Why is it difficult for developers to learn another programming language? And before I begin, I'd like to thank my co-authors on this work, Colton Boda, Tysus Barik, and Chris Parnan, my advisor. So I'd like to start the talk with a problem. And the problem is developers have to constantly learn languages. For example, take this Java professional programmer considering Kotlin for their new project. In this blog post, they list several things that make it easy to learn Kotlin because, both languages are statically typed and, object-oriented programming is the way to go there. But then they also list a couple of differences that keep coming back at them, such as the types preceding names in Java versus types following names in Kotlin. And Java classes are not final by default, whereas in Kotlin they are. And a programmer like this has to go through this many times, and by the end of this, all the differences were too much for them, and they went back to Java. And they have to go through this process over and over again when they switch projects, they go to a new job, they're considering new languages. So this paper is motivated by the question of why can prior knowledge sometimes make it hard to learn another programming language? And how can we begin to understand this issue? So we turn to a popular theory in neuroscience and psychology called interference theory, which basically describes the ways in which memory can either facilitate or interfere with new information. But what does that mean? I'll give you an example. Let's say you go to the grocery store to pick up some bread, right? And you walk to the familiar location for that bread, but all of a sudden, it turns out that it's a sauce aisle now. And your previous knowledge no longer works and interferes with this new information. And what's funny is the next day you come back to the same location and you're back to the sauce aisle, and it really drives home the point that it's instilled in your brain. On the other hand, let's say you're looking for the new Impossible Burger. It should be in the frozen section because that's usually where the meats are kept. and you walk over there and you do find the Impossible Burger there. And in this case, your previous knowledge facilitates this new information. In the same way, if we go back to our example, then we can say, Java knowledge that transfers over well, we can call that cross-language facilitation. Things that don't work well, we can call that cross-language interference. And so for the first part of our study, we looked at Stack Overflow posts, and we wanted to, take the first step of asking, like, does cross-language interference occur out there in the wild, and how can we detect that? And so our method was basically to look at cross-language posts, and we filtered our list of languages down to 18 different languages and 15 different pairs. We looked at posts like this one right here on the left. And what we did was qualitative coding of each one of these posts. Basically, we labeled a post correct if the asker is making a connection to a previous language and making correct assumptions about the target language. And this is revealed by the accepted answer. On the other hand, we label it incorrect if they're making incorrect assumptions about that target language. And so here's a quick example of how we did this analysis. Here, our programmer is trying to replicate an expression in Python, and they get this setting with copy warning. And they even say, maybe I'm thinking too much in R terms. So this is a very clear example of how this R knowledge is kind of interfering with their Python learning experience. And the accepted answer, of course, point this out. This is incorrect. You should use this syntax, which will get rid of that message. So what are the results for RQ1? Well, it's not that uplifting in that 61% of the 450 posts contained incorrect assumptions about the target language, and only 39% were correct. And some of these pairs were particularly prone to interference, which is interesting because if you look at the languages in each pair, they look very similar. And some of them fared better, but not that much. So we still had some questions. So we moved on to phase 2 of our study, where we actually talked to professional programmers, and we were interested in 2 questions. How do experienced programmers learn new languages, and what do they find confusing in this process? And so we talked to 16 participants who were undergoing a recent transition to a new language, and we asked them about their background, first steps in that language, what obstacles did you come across, and their general kind of learning strategies. So for the analysis, we did a thematic analysis on the transcripts, and we came up with high-level themes that aim to answer these 2 questions. So here's the result for RQ2, but I'm only going to cover 2 of these learning strategies. The first one being, we noticed participants were kind of using this opportunistic learning strategy, foraging for quick, accessible resources like cheat sheets and tutorials instead of, traditional things like books. We also noticed that participants tried to relate new languages back to the previous languages they were familiar with. P10 says they loosely take ideas from working in another language, and P15 says it takes them more than halfway there. But as you can imagine, when you start doing this comparison, you run into issues. And almost in anticipation of this, some participants started with a clean slate. So what do experienced programmers find confusing? Well, a bunch of different things, but I'm only going to point out 3 that I think are kind of interesting. First of all, when programmers are making a paradigm shift, they have to do this thing called mind shift. So you have to mentally shift the way they program in this new language. P5 went from C++ to JavaScript, and they weren't used to all this asynchronous programming and the front-end programming that's involved in JavaScript. Related to that is the issue of little to no mapping to previous languages. So when you're doing this comparison exercise, it doesn't work out if there's nothing to relate to. P10 could not relate this idea of borrow checker in Rust back to C# because that doesn't exist, and they say it's somewhat esoteric and it's an alien concept for them. And lastly, retooling is a challenging first step. This example is interesting because P9 went from JavaScript to Scala, but they're using IntelliJ to do their Scala work. And they say, part of the problem is IntelliJ is aimed at the Java developer, and I'm using SBT, which is from the Scala world, and sort of importing SBT into the concepts and the IDE of IntelliJ. So I'm looking at dialogues that are all about Java and which JDK, and that doesn't map to what I wrote in the declarative SBT language. And so the final takeaway I want you to have about this paper is that, we talk about transitioning from language A to language B, but in fact, we also should talk about transitioning from language A's ecosystem to language B's ecosystem. And so what are the design implications of this? What can technical authors, toolsmiths, and programming language designers do to help reduce these issues? Well, I'm going to discuss the first one, which is design documentation that kind of reduces interference and tries to support knowledge transfer. The Rust documentation is a good example of this. They continually make comparisons to C and C++. The second one being when we start to talk about tools, we can try to build automated tools that provide, on-demand feedback. A really simple example is, going from Python 2 to Python 3. If you do print as a statement, you get this nice compiler error message saying maybe you meant to do the function call instead. And finally, we should not only support languages, but also language ecosystems. So P13 went through a particularly drastic experience, a tech shock, if you will. Everything is different, not just the programming language, the IDE, source control, everything is different. So what can we do in this IDE arena? Well, one idea is the language server protocol out of Microsoft, and it's this idea of, can we agree on a protocol for really common editor functionalities and turn the problem of having to make a plugin for each language, for each new tool that comes out, to just implementing a language server for that particular language. And what this requires is a partnership between language designers and developers and toolsmiths so that we have a unifying kind of tooling experience. And with that, I'd like to conclude my talk and open it up for any questions that you may have. Thank you so much.
Yeah, thank you very, very much. Also from my side, this was an excellent talk. Congratulations again on your distinguished paper. And really a lot of things are happening in the background. So I think this session is quite, I don't know, it looks to me like one of the most interactive sessions. We have a lot of questions and a lot of thumbs up and so on. One popular question is, I think you mentioned this a little bit in your final part of your talk. Is the difficulty greater when switching to language with the same paradigm, like Java and C#, or to language from very different paradigm, like Java and Prolog, for instance?
Yeah, that's a really interesting question. It feels like, I pointed out the similar languages. It feels like that should be easy, but as we saw from both Java Kotlin example and, C# and Visual .NET, it seems like both are hard, right? Things are very distant, then that's hard. If things are very similar, then you have higher interference issues. So I think both are difficult and we need to.
Yeah, cool. One other question that I also thought about during the talk, so it's also quite popular here, is about maybe kind of threats or risk to research question one. That people doesn't ask question on Stack Overflow if everything works as planned. So in Stack Overflow you have a kind of perhaps biased people.
I'd like to say the flip side is actually scarier, because what questions aren't people asking about these transitions, right? So yeah, it is very true that this is a valid threat, but we just like to point out that this was a very convenient way to study this this issue. But yeah, the flip side is also scary. Questions.
Yeah. Okay, so one might have to follow up and check perhaps also different kind of sampling or different kind of population. Good. So I'm just checking here. Maybe one more question. Do you take into account question that might contain both correct and incorrect assumptions?
Yeah, those were a little bit tricky, and what we did was we tried to kind of reconcile that between the co-authors, and if we could not agree at all, we just kind of drop that one.
Sure. Sure. Okay. Good. So I think time is over. So thank you again very much. And now we can move to the next and final presentation of this session, which is going to be a short talk. Now we are jumping into Brazil, I think, Sao Paulo. And we have Leonardo Leite, who is going to talk about gray literature in open source. So the floor is yours. You can share. You're already doing it. So please go ahead.
Okay. Thanks so much. So my name is Leonardo Leite. I'm a PhD student at the University of São Paulo in Brazil, and I'm going to talk about the use of documents produced by open source communities in software engineering research. And this research, it has been conducted mainly by Mrs. Wayne, a master's student in our research group. So, open source communities produce diverse types of artifacts, such as technical reports, white papers, documentation, magazines, and blog posts. This kind of information, not controlled by commercial publishers, is known as gray literature, GL. Using GL for software engineering research has advantages of its own. It provides more up-to-date information, it provides more negative in our results, and it helps to identify gaps in the academic literature. So given the vast amount of gray material available there, we claim that researchers should first examine and explore such artifacts before taking the time of open source contributors. However, there are challenges for conducting gray literature reviews, GLR. There is no precise methodology or guidelines for about how to handle the specific challenges of gray material. Therefore, based on our experience in conducting a gray literature review about the Linux kernel development model and based on guidelines for systematic literature review, and this work represents some challenges and adaptations for conducting this kind of review. So it's about planning the review, selecting data sources, and selecting the documents. So a first concern is the credibility of material, because there are a lot of opinion-based gray material. And if you don't take care, you can even include fake news in your data sample. So we recommend control factors for coping with this issue. In our case, we required the organization or author publishing the document. It should have some reputation. And the statements in the document, they should be supported by data, like, for example, Linux artifacts. Moreover, the terminology for gray material can be wider than for academic papers. Therefore, you need to define synonyms for your search terms in the query. For example, we expanded development as culture, practice, rules, and structures. But on the other hand, usually search engines for finding gray materials, usually they cannot handle complex queries. Therefore, you need to sharpen your query to be both broad and simple, what it's hard. Usually, for traditional reviews, we employ very well-known and prestigious digital libraries. But for gray material, choosing these data sources, it's not so obvious. So you need to define a process for choosing these data sources. You can web search for them, consult experts, gather snowballing references from key documents, or classify data sources according to some criteria. For example, in our case, we classified our data sources as dealing specifically with the Linux kernel or dealing more broadly with IT or open source subjects. So we prioritize the evaluation of specific data sources first. In any review, there is also a phase for title-based selection, but for gray material, the problem is that titles, many times they are not accurate. They can also be misleading. Therefore, we recommend speed reading. You can search for the keyword in the document to check if it's really pertinent for your case. Well, following these guidelines, Mrs. Wen is conducting the review about the Linux development model, and she's finding some very nice, interesting results that are not so explored by the literature so far. Anyway, we help the strategies reported here. They can help to boost the use of gray material for research on about open source communities. So that's all, really. Thank you so much.
Yeah, thank you very much also for a very good presentation and being on time. So while waiting maybe for some questions, maybe I can start. So, I mean, what do you think? I mean, what are your maybe most important recommendations for both sides, maybe the research community and the open source community from your study? What can we learn, so to say? What should we do different?
Okay, for the academia, it's more about embracing this kind of materials, not only referring to academic papers. But you have to be aware of the challenge because the amount of material is too huge. So it's a challenge. But in this case, for the open source communities, I believe it's not so much to talk about. They are producing this kind of documents, so they are already kind of helping the researchers in an indirect way.
All right, so we have one question here, basically about the evidence for your recommendations. So, what's the basis? What's the evidence? Do you have empirical evidence for the recommendations you're providing, or are these hypotheses, or what?
Okay, so this track is near. It's more about new ideas. So we don't have strong experience, but it was based on our challenges. Because we started to perform this review, we found these challenges. It was necessary to make some adaptations. So it's kind of a way to start this discussion so the community can formulate a better way to do this kind of review. But it's a start for a long way for the software engineer community, I believe.
All right. So basically, this is a lot of new ideas, as also the track is supposed to provide. So I think we don't have more questions here. I would like to thank you very much also for this presentation. I would like actually to thank again all the speakers. I felt this session was really very interesting. All the talks were very good, very much on time. And in particular, I was actually quite impressed by the amount of interaction and the questions. Please keep in mind that you can still join the authors and the presenters either in the video chat lobby or in the exhibit hall or on Slack. With this, I thank you again for joining us on a Friday afternoon, and yeah, have a nice weekend, and bye-bye.
analyzing candidates' experience with hiring process can give insights about the reasons they drop out of the hiring pools. But where can we find candidates' comments about their hiring experience? One resource is employer review sites, which can be assumed as Yelp for employers or companies. So one of the well-known employer review sites is Glassdoor, which has built a database of more than 8 million company reviews. And all the data is generated by companies' current or former employer and candidates who went through their hiring process. So here is how a part of Glassdoor website looks like, reporting on Microsoft. As you can see, there are more than 9,000 interview reports for different positions in Microsoft. For example, there is 1084 reviews on software developer engineer position and 655 reviews on software engineer position. And here is an example of a candidate's report on Microsoft hiring process. And you can see that, for example, the candidate had a positive experience with the hiring process and got an offer. And also they reported how they applied to the company and shared their experience with the hiring process and technical interview. To select our data, we limited our data collection to companies which appeared in the software category for Fortune 2000 and had at least 50 reviews on Glassdoor. We ended up with these 19 companies. We scraped more than 10,000 reviews from Glassdoor on reviews spanned from 2009 to 2019. Reviews were filtered on software engineering and software development engineering roles. We use qualitative analysis to analyze the collected reviews. In the first stage of our qualitative analysis, we use descriptive coding and assigned short codes and labels to capture and summarize the salience of the reviews. And in the second stage, we performed a reflexive thematic analysis to organize and cluster the codes and then situated those themes within each stage of the hiring pipeline. Here are the themes that we found in each of the stages of the hiring process. We found 2 themes in the contact stage: paying attention to details and responsiveness. These themes show that problem can occur when key requirements about the position are not properly communicated or representatives from the company do not provide timely responses. A negative experience on paying attention to details report: I specifically applied to Seattle. My resume said I am located in Seattle. My LinkedIn says I'm not interested in anywhere by Seattle or New York. But she goes and shoehorns a San Francisco team onto my radar. And a positive experience reports: they gather info on your interests and ensure the role match them, confirm your location preferences, work authorization, and visa requirements, and understand your decision timeline and desired start date. In preparation stage, we found that the most important impression that the candidates got were from interview scheduling organization and how companies are clear about what to expect from them. For example, if the company offers preparation package, to what extent they stick to the topics they highlighted in their packages as requirements. So let's see a negative experience example on interview scheduling. When I initially realized I was going to be interviewed for this position, I was enthused and immediately began to prepare. However, this quickly waned as my interview was rescheduled 3 times, which as a candidate provides a terrible experience, especially as I'm currently employed full-time. On the flip side, the candidate reports that they were positively surprised that the company cooperates with them, scheduling their interview to be held on Saturday. Interview stage was the richest stage theme-wise, and we found 5 themes for this stage. Candidates expressed their satisfaction or annoyance based on the extent of interviewers' involvement, interviewers' knowledge and experience, interviewers' friendliness and relevance of the technical interview questions, and impression from the on-site interview. candidates were affected by levels of passion of their interviewers as the company employees, and they got a vibe whether the company is a right place to work with. We found that regular status update and getting feedback after interviews played an important role in candidate satisfaction and the extent that they found the company to be professional and appealing to work with. In a negative experience, I mean, an example of it, even the candidate discouraged their peers by saying they don't have time to update a status suggestion. Go for a better opportunity. So it's super important. Even they can discourage their peers too. And finally, and possibly the most important theme was offer and negotiation, in which anything goes wrong in this stage, it could be a large waste of time and resources for companies and candidates alike. So let's see what went wrong. An example was, I guess that their strategy is to lowball everyone unless you have a competing offer. The team matching progress is extremely slow. Took around 3 months to finish everything, way too long. Declined the offer without hesitation after team matching. Another candidate was happy as the hiring committee approved the application in a week, followed by final offer a few days later. So it was super fast for them, and they enjoyed that. So besides the important themes we found, which interprets the most important reasons that candidates drop out of the company's hiring pool, our study also compiles guidelines for each of the hiring process stages based on the things that we learned from candidates' feedback. So here I want to tell you about the last guideline we suggested for the last stage of the hiring process, offer and negotiation stage. So our guideline is negotiate not just the immediate offer, but invest in long-term career growth. So qualified candidates in multiple offer situation may be forced to make a rush decision. As a result, the engineer may start searching for a more suitable position. So giving candidates appropriate time to make an informed decision about joining the company benefits both the candidates and the company. And also, the offer can also go wrong when candidates feel slighted. Either they feel that the company is lowballing them, or they are not giving a role. They are not given a role that they deserve based on their experience. So, if companies provide transparent information about their bonus structure, vesting schedules, and career ladder, then candidates can be reassured that they're receiving a fair offer relative to others with the same level. And that was pretty much about it. And thank you so much for your attention. And I'm here to answer any questions that you may have.
Thank you, Mehnaz. That was a very interesting talk. So before we move on to the questions, I would like just like to quickly address something. At the beginning of the talk, there were some technical issues. So audience may not have heard like first 1 or 2 minutes of the talk. So we're really sorry about that.
Yeah,
now,
okay.
let's moving on to the questions that we have there. I see a lot of questions, so I'll just start the top one that is on the top. Did you note any gender differences from respondents at any of the stages?
Well, yeah, that's an interesting question. And I would say yes, although we couldn't build a theme based on that. But yes, for example, if you know, it is not apparent that what is the gender of the person who is leaving a review on these sites like Glassdoor. But I would say that yes, some of them, for example, complained about the gender of the interviewer. So, for example, the complaint that, for example, this interview was held by just males. So that's apparently saying I would say that yes, there are some gender differences and some kind of probably stereotypes even existing in there. And I would say that probably in the future we can also, as a part of our studies, pay more attention to that gender biases sort of things.
Awesome, thank you. The next question is, which companies have you considered in the paper?
Oh, I think that was the part that the audiences missed, but basically I also reported them. And here was the 19 companies that we saw, that we run the study. And actually I told the audience that our criteria was that these companies appeared in software category of Fortune 2000, and they had at least 50 reviews on Glassdoor.
Oh, thank you. So we have time for one more question. So a lot of these issues apply to HR and recruiting. How do I improve this as an engineer involved in the hiring process?
I'm not sure if I got the question right, but do they mean that from the perspective of an engineer, what should we do? Or
yes.
So, you know, that's another completely different scope. We actually did a study in our Hiring is Broken paper that was from the perspective of the candidates. But in this paper, we were basically more aligned into a company side, and we wanted to debug that was going on in the hiring process in order to help the companies. But in that Hiring is Broken paper, if the audience go and read that paper, and they will see that we compiled the difficulties that the candidates faced.
Awesome.
What was the problems? Yeah.
Awesome. Thank you.
Yep.
So I see there are some other questions that we cannot take due to the shortage of time. So if you want to ask the authors any more questions, I would encourage the audience to follow up on Slack or in the paper specific chat. So, Mehnaz, thank you again for the excellent talk.
Thank you so much.
Thank you. So, our next talk is from RE Cares to SE Cares, Software Engineering for Social Good, one venue at a time, and will be presented by Jen Hayes. So, Jen, the floor is yours.
Okay, it's asking to start my video, but I'm trying to share my screen. Okay, there it is. Hi, my name is Jane Hayes, and I'm from the University of Kentucky. And this is the story of RE Cares and why you should undertake a similar venture at your conference in 4 minutes or less. We're an international group of researchers, practitioners, and students, and we were interested in how we could give back as part of our ongoing participation in the IEEE Requirements Engineering Conference, or RE. We have a lot of skill, knowledge, background, ability. We come into these different locales of our conference each year. We sort of swoop in and swoop back out. No one maybe even knows that we were there. But what if we could leave behind some positive benefit to society? The idea is simple. Identify a stakeholder in the locale of our conference who's having a positive societal impact and also has a software need. We work with them a little bit before the conference, and then at the conference, we have a full up requirements elicitation, and then we work on design, and we have a full day hackathon where we prototype some important features. And then we move the product into open source so that others can continue its development. The stakeholders are right there with us at the conference. They're working with us. The result is a highly interactive, lively, mutually beneficial experience. We found that the RE attendees loved it and also gained other benefits besides helping impact society in the form of using the projects as case studies, using the information for their research, dissertation evaluation, and so on. We've run this twice now. The first time was at Banff in Alberta, Canada in 2018, where we worked with emergency response, and we developed a secure, private instant messaging app to help emergency responders communicate with each other. We also had a good experience in 2019 in Jeju Island, South Korea, where we helped those folks come up with ways to make it easier for their mobility challenged residents and tourists to use public transportation on their small but very popular island. And what we're interested in now is how can we broaden this idea? How can we generalize this idea so that we could have, for example, ICSI cares, ICSME cares, ISRE cares, and so on. So what we would like to do is get you inspired to learn more about this and to join us. Now, there definitely is some organization that needs to happen prior to the event. There's many activities that go on during the conference. For example, we have a one-day workshop where we perform the requirements solicitation, and then we have another mini requirements workshop during the first day of the start of the conference so that we can get others to join us. Then we, the organizers, and others who are interested, work on the design, and then we have an all-day hackathon. We're forming a steering committee to help explain to others how they can undertake an RE Cares type event at their own conference. We think that you would find it very beneficial. We've also written several papers on this now, including this ICSI SEIS paper, a paper at ISRAE last year, and an IEEE software article last year. We also have all of our organizers that are standing by now who can go into breakout rooms and talk to you about how you can do this at your own conference. So please join us because we know ICSI cares.
So thank you, Jen. So while we are waiting for questions, I have a quick question. So actually, one question just came. So I'll just read it. Really great and meaningful idea. Can you tell us something about what happens after the prototype goes to OSS? Are your two apps in use today?
Okay, absolutely. So on the first one from the 2018, that was done in Ruby on Rails, and we had two different organizations that agreed to continue its development. One is a meetup group for Ruby on Rails, and the other is, I won't be able to think of their name now, the Ruby Brigade, I believe it is, out of Louisville, Kentucky. And they're a Code for Good organization. Now, we just look periodically at the GitHub. We don't actually continue following or push people to continue development. But, and then in 2019, we have the Cal Poly Code for Good Club is considering picking up, continuing maintaining and continuing development of that. The 2019 project, though, there were actually 13 stakeholders that helped us, and 6 of them were computer science students, either high school or college. So they were actually trying to continue some of the development themselves.
Okay, so thank you. So the next question we have is, how much uptake have the outputs from the hackathons had? Are the projects still actively developed?
Okay, I think I might have touched on that in my prior answer. So I don't know on the 2018 project. On the 2019 project, like I said, the folks from Jeju Island were continuing development, and then also the Cal Poly students were considering continuing the development.
Awesome. Thank you. And with that, we are out of time. So thank you, Jen, again for the nice talk. So we will move on to the next speaker. So our next paper is Deep Learning for Smart Sewer Systems, Assessing Non-Functional Requirements, and it's going to be presented by Hemant. Hemant, the floor is yours.
Thank you. Hi, my name is Hemant Kodapati. I am from University of Cincinnati. I'm a PhD student, and I'm going to present you our paper on deep learning for smart sewer systems, assessing the non-functional requirements. So to start with, wastewater management is very important in maintaining the health of the people and preventing environmental damage. So the water flowing out of the houses, industries, or streets, etc., have to be collected and treated in a water plant, or else the effluents coming from these water will be mixed in the water bodies like rivers or lakes, etc., which might cause many health issues. So a combined sewer overflow are the water pipes that go underground under the roads and collect these waters and send the wastewater to the treatment plants. Over here, we can see the figure of this combined sewer overflow, where the water will be sent to the treatment plant until it reaches the safe capacity. But if it's above the safe capacity, the water will be overflowing to the rivers. So there are around 860 cities in United States that are equipped with this kind of wastewater systems and combined sewer overflows. In Cincinnati itself, we have around 200 CS force working. So the Metropolitan Sewer District of Greater Cincinnati has always been looking for advanced technologies that could predict this overflow from the sewer source to prevent the environmental damage. And we know that many researchers have already proved that recurrent neural networks are one of the best neural networks that could be used in prediction, especially when we have time series kind of a data. So we have used this RNN to train and predict the overflows of the MSDGC data. And as we know, there is a lot at stake of the if the RNN has mispredicted an overflow label. So we have to test the non-functional requirements such as robustness along with the functional requirements. In this paper, we have come up with a metamorphic relation to test the robustness of different variants of RNNs in the face of missing data. So before we go ahead, I'll give a small example of what metamorphic relations and what metamorphic testing is. So when we don't have any kind of expected output, it will be impossible to test a case. In this situation of missing oracle, we rely on metamorphic testing, which uses metamorphic relation to know the expected outcome. So here is an example where sin x to 100 decimals is hard to test until and unless we know the 100 decimals, but we can use the metamorphic relation sin pi minus x equal to sin x to easily test the relation. Over here, this is a snippet of the data that we have. Due to confidentiality reasons, we cannot show the exact data, but these are the futures and this is the overflow label that we are going to predict. Our idea comes from the inference that if a label is gone missing at this particular point, will the RNN be able to predict the consecutive label, which is over here, correctly? So this is what I have written from the data set. So this is the main idea of our paper. So this is how RNN works at the structural level. So when we have input at time t-1, it goes into some kind of hidden layers, and then the prediction output t-1 will be there. So the ground truth label for this output t-1 will be presented at input at t, and once it sees the distance between the ground truth versus the predicted output, there will be a change in weights in the hidden layers of RNN. This change in weights of hidden layers of RNN are always in decreasing order. So our source test cases come from this particular relation where change in weight at t-1 should always be greater than or equal to change in weight at t, and that should be greater than or equal to change in weight at t+1. When we have a missing label at time t, the follow-up test case will be something like this. The change in weight at t-1 should be greater than or equal to change in weight at t+1. If it satisfies, it's a successful test case. If it doesn't, if it's less than t+1, then it's a failed test case. We have tested this experiment over 3 different variants of RNNs: long short-term memory, LSTM, gated recurrent units, GRUs, and independently RNN. And these are our test results over here. So we have collected 8,500 test cases from all different variants of RNNs, and this is how results look. LSTM has failed over 28.4% of the test cases, while GRU failed 42.5%, and independently RNN has failed 29.1%. This shows that RNN is much robust than other 2 different variants of GRUs in this particular data and in this particular case of missing labels. So to conclude our research, since the deep learning methods are tremendously increasing due to their technological advances, we have necessity to test non-functional requirements along with the functional requirements. So in this paper, we have shown that robustness of RNN will maintain the machine to be accurate even in the less ideal or less robust conditions. We have presented a metamorphic relations for assessing the non-functional requirements of RNNs, and the non-functional requirement taken over here is the robustness. These results will present a recommender system for RNN solution candidates in overflow prediction, and we also infer that this kind of metamorphic relation can be generalized to any kind of time series predicting machine learning models. Thank you, and I'm open for questions.
Thank you, Hemant. Nice talk. So while we are waiting for questions, I have a quick question. So what would be a follow-up study that you would like to do based on the observations that you have?
We are concentrating on the non-functional requirements since we have covered the robustness of this study. So we are going for other non-functional requirements like correctness of the models and all those things. And our main focus will be on testing non-functional requirements of these deep neural network models.
Awesome, thank you.
Thank you.
So at this point, we don't have any other questions, but if audience comes up with questions, as I said before, you can find the authors in the chat, the Slack. And so now we will move on to the next talk. Thank you, Hemant, again. So our next talk is Refactoring Community Smells in the Wild. The Practitioner's Field Manual will be presented by Gemma. And so Gemma, this floor is yours.
Okay, so good afternoon, morning, or evening, everyone. I'm Gemma Catolino from Delft University of Technology, and today I'm going to present our paper that has the goal to provide refactoring strategy for mitigating and solve community smells. Two things before started. This is a joint research project together with the University of Salerno, Eindhoven University of Technology, and Geronimus Academy of Data Science, and another one that we obtain the available and reusable ACM badges. But let me introduce briefly the context of our paper. So, as you know, software development is a social activity. So the way developers communicate and collaborate can affect the software quality. And for this reason, companies continuously struggling with issues related to team dynamics, team culture, and so on. Indeed, as a proof of this, previous study suggests that the 56% of projects do not fail because of technical factors. Indeed, during software development, it might happen that some conditions create suboptimal organization and communication. And this is a clear symptom of a presence of community smells, a social technical characteristic and patterns which may lead to the merging of social debt, and that can lead to increased project costs. But let me provide you an example about one particular community smells. You need to think to the development team as a community. So here there is the community, and it might happen that one of the members work in a respective manner compared to his or her peer in terms of tasks, decision, and communication. And this is the definition of a community smell that is the lone wolf. But, well, what we know about community smell? In a recent study of Tamburi et al. That analyzed community smell in open source projects, we know that community smells regularly affect open source community, that they are considered harmful for the sustainability of software projects, and also that developers deal with them changing the underlying community structure, and that some socio-technical factors can predict their emergence. And in particular, in our previous studies, published at Software Engineering Society track and following extension, we focused on understand which are the factors related to team composition, team information that can explain a way or another the presence of community smells. And after that, we decided to take action and provide refactoring strategies in order to solve and mitigate community smells. In particular, we focused our attention on 4 different community smells. You already know lone wolf, but let me introduce the other 3. As for the organizational silos, these smells occur when there are community siloed areas that do not communicate with each other except through 1 or 2 of their respective members. And here there is the schema of this community smell. As for the black cloud, these smells appear when there is an excessive information overload to the lack of structured communication. And finally, radio silence. These smells appear when one team member interposes her or himself into every formal communication across 2 or more subcommunities. In order to extract our refactoring strategies, we conducted a survey. This survey consisted of 5 main sections, one related to background, where we asked to our participants about gender, size of company, team size, role, and self-evaluation about their skills in terms of programming and management. and 4 sections related to 4 different scenarios. Each scenario corresponded to a particular community smell. But pay attention, we did not explicitly refer to, hey, this is a community smell, but we just told them a story. For example, here, there is the story of the lone wolf. During the development, you recognize the presence of individuals who carry out their work independently from the decision taken by the community. And after that, we asked them, has this situation ever happened to you? And if yes, how did you address it? With the first question, we wanted to analyze the relevance of community smell. But with the second question, we wanted to extract refactoring strategies. And in particular, starting from the second question, that was an open question, so an open answer, we use a grounded theory methods. In total, we received 76 answers. And as I said before, in order to pass from an open text, so from an open answer to a particular refactoring strategy, a particular label, we followed the grounded theory methods. So we did several rounds, and during each round, all the authors of the paper discussed it with each other in order to find an agreement, and we also rely on the Cohen-K coefficient in order to go on every step that we made. And finally, we arrived to the theoretical saturation, and that means that the classification was completed. But now let's move into the part of the results. So, as for the first question, has this situation ever happened to you? We can in a way confirm the results of Tambour et al. Indeed, it seems that community smells are relevant, and in case of, for example, lone wolf, the 66% of the participants deal with the lone wolf. And an interesting thing is that people that deal with lone wolf belong to a very large company with a very big team. As for the refactoring strategies, of course, I don't have enough time for explain all the refactoring strategies. In this slide, I show you the most mentioned and common strategies, but in general, for each of the community smell, we found around 6 strategies. I have backup slide in case, but what I can tell you is that refactoring strategies really are related and are very close to the description of community smell. For example, restructure the community is the most mentioned strategy for organizational silo that has a clear organization problem. For example, in case of Black Cloud that has problem that is related to a communication problem, the most mentioned strategy is about improve communication plan. And the last one is introduce a social sanctioning mechanism. This is very interesting because, for example, for lone wolf, some participants suggest to, from one side, to try to monitor and mentor the lone wolf, but on the other side, to fire the lone wolf. So we are aware that we need to confirm these refactoring strategies, and we want to plan to do interview, so more in-depth interview, but we believe that this is the first step toward the definition of concrete heuristics to remove community smell and improve their detection. For this reason, as a future work, we plan, of course, to involve more participants, involve more community smell, and also analyze the open source analysis perception, because our participants belong to closed source company. And that's all. Thank you for the attention. If you have questions, free to ask. Or you can also contact me on email. Thanks.
Thank you, Nima, for the nice presentation. So I have a quick follow-up question. So can you tell us something about like the refactoring strategies for the Black Cloud?
Sorry, can you repeat the question?
Yes, please. So can you give us some insight regarding the refactoring strategies that you found for the black cloud smell?
Yes, yes. And okay, okay, I'm still the screen sharing, so I can show the backup slide with all the refactoring strategy related to black cloud, if you agree.
Yeah, please. Sure.
So yeah. So why? Okay, yeah, I need to unskip the slide.
Yep.
Okay, so in general, we noticed that the most mentioned strategy is about create communication plan. Indeed, the problem of black cloud community smell is the fact that there is this overload communication due to an unstructured communication plan. But, for example, another strategy is about restructure the community, because maybe there are people that do not communicate each other, do not follow hierarchy. So that is why maybe participants suggest also to restructure the community. And finally, also the possibility to introduce a social sanctioning mechanism, so motivating people to act as expected. Otherwise, you need to fire them in a very harsh way, but you need to motivate people to act as expected.
Awesome, thank you. So one question from audience: it seems like radio silence is more like hands in too many pots.
In which sense, hands in too many pots?
So I guess we need to push this question, because there is no way to get a clear clarification from the audience. So whoever asked this question can reach out to you after the session.
Okay, maybe I can join the chat and answer the question. Yeah.
Awesome. Another question is: have the respondents described their experience with well carried out refactorings? Did you encounter cases of refactorings having good results?
Yes. For example, in particular, one example about organizational silo was very nice, because actually the participant, the first interesting thing that he or she, I don't remember the gender, but recognize the existence of this community smell. And it seems that after he or she applied the restructure of the community, the things went well. But of course, we have very just few examples. But of course, that is the reason why we want to do interview, in order to, okay, these are our refactoring strategies. Please tell us your experience, and let's see if they work effectively.
Awesome, thank you. And with that, we are out of time. So thank you again, Gemma, for the nice talk. So
you're welcome.
So moving on to the next speaker. The paper is Building Trust in the Untrustable, and it will be presented by Emilia. So Emilia, the floor is yours.
Can you hear me?
Yes, we can hear you.
Good afternoon. Trust is the crucial concern driving our society, and trust plays a key role in the adoption of technical innovations. Although the advancements of autonomous driving would decrease the number of accidents significantly, people will still not trust self-driving vehicles. To solve this problem, in our paper, we introduce a method for building sustainable trust. We build the trust of a human being into a vehicle that becomes increasingly autonomous. And at the same time, we build the vehicle technical trust into runtime software updates that gradually replace user actions with autonomous behavior. In this way, the driver and the vehicle evolve together in a process that supports the interchange between a human trustee and a software smart agent. An integrated concept of operator and system that supports the building of trust into dynamic updates of safety critical systems with direct influence on the liabilities of OEM. The method we propose is derived from the neurological feedback loop of human behavior. It is directed towards engaging the driver into trusting and evolving the autonomy of vehicles. So through supervision, the driver gains trust, while the vehicle gains from proven in use safety arguments and reputation of behavior exercised in multiple situations. We have created the new concept of runtime building of trust into dynamic updates in the past years. We have introduced the technical aspects of trust in 2019 at XC New Ideas and Emerging Results. There, we have showed how we can build trust into dynamic runtime updates without executing behavior that can potentially contain some malicious code. The predictions is performed through execution of the digital twins instead of the software smart agents that we might suspect of having some malicious behavior. In the paper this year at XC, Software Engineering in Society, we bring forward the concerns of the drivers. We basically show how the technical trust and the human trust can work together in a win-win fashion that brings forward the trust of our societies into self-driving vehicles. So I'm ready for questions.
Thank you, Emilia. So at this point, I don't see any questions. So I would like to remind the audience, if you have any questions, please post them in the Slido, in Clouder. Okay, then, so I guess we can move on to the next speaker. Thank you, Emilia, for the presentation. Okay, so our next talk is developing software for motivating individuals with intellectual disabilities to do outdoor.
Was going too slow. I told you to go into the right step.
Sorry for the interruption. So our next paper is developing software for motivating individuals with intellectual disabilities to do outdoor physical activity, and it will be presented by Carlos. So Carlos, please, the floor is yours.
Yes, thank you very much. So I'm Juan Carlos Torrado. I am from the Norwegian University of Science and Technology, and I'm presenting my short paper that is about how can we create mobile games to motivate individuals with intellectual disabilities to do outdoor physical activity. This is interesting because sedentarism is a really serious problem that affects health in the long term worldwide, and which is even stronger for people with intellectual disabilities, and even stronger now with the pandemic. So we have been investigating how can we craft the software engineering process and the software development process of mobile games to satisfy the needs of the people who have this issue. So our research question is how can we develop gamified applications that motivate young adults with intellectual disabilities to do outdoor physical activities, specifically for outdoor physical activities. So we have to focus on the navigational assistance systems, specifically crafted for this population, and also what is important when designing games. So we want to give an additional level of abstraction in our study by providing some guidelines that can be useful for other researchers that develop applications for this population. So we have used a research method that is composed of 3 main steps, beginning with a literature review of other applications that serve this same purpose, and some interviews with experts, being tech company leaders, tech designers, and professionals of people with intellectual disabilities and in health-related centers. So this first phase made us develop our first low fidelity prototype and the first version of the guidelines that I mentioned before. And then we made a focus group with more tech designers and more nurses and caregivers and teachers of people with intellectual disabilities, which allowed us to make our working prototype and the second version of the guidelines. So with this working prototype, we made a pilot user study in which we use this prototype to take people with intellectual disabilities to make to do hiking related activities outdoors with their caregivers and other stakeholders. And after the user study, we made some group interviews to gather their impressions on our prototype and see what can we refine and improve for further testing. So after this, we got the final working prototype of our application, from which is our main result. I can show you so a sneak peek of these results of this prototype. So the prototype is a game application that is to be used when the people with intellectual disabilities go out to do hiking with their caregivers or their friends or their family. So we found out that the most interesting part for them and the part that they pay the most attention is the social interaction. So if they can go hiking, but they have like challenges and rewards that can be used to interact with the caregivers and with their friends, this makes them get more engaged with the social activity and with the physical activity itself. So we also found out that the navigational part of this game was better solved by using street level pictures, not maps, because the maps required a higher level of abstraction that is too cognitively demanding for them. And we also crafted all the interface following friendly colors, soft colors, and also alternative and augmentative communication techniques like pictograms and simple icons. So the prototype is one of the main results, and the other one is the guidelines that can be found in the paper. Thank you very much for having listening to this presentation. And if you have any questions, you can refer to my email, which is the first one in the list, or the questions from the Slack. Thank you very much.
So we have time for like one quick question, and there is none at this point in Slido. So I have a quick question. So again, I know that's not part of the paper, but did you collect any kind of information after the users use this application, like some people, and was there any effect in terms of the activities they were doing?
Yeah, in fact, the engagement and the motivation is the part that we focus the most. Without game, without any kind of application, they do not usually feel motivated to do any kind of physical activity. But if they have any game, they which makes them interact with their friends and with their caregivers, it makes them do. So the difference with the app can be as strong as the difference between doing the physical activity or not.
Okay, awesome. Thank you. Thank you, Carlos. So
thank you.
Let's move on to the last talk of this session. The paper is Designing Edutainment Software for Digital Skills Nurturing of Preschoolers, a method proposal, and will be presented by Adriana. So Adriana, the floor is yours.
Hello. Hello, everyone. Today I will give you a talk about designing edutainment software for digital skill nurturing of preschoolers, a method proposal. And this paper is written with my colleague Grigoreta Sofia Cojocar and Ana Maria Moldovan. First of all, I will present you the context and the motivation of our research. In the European Union, where our country resides, there is a trend of digitalizing the society. And the statistics show that there isn't enough level of digital skills of the young population of the European Union, and this has a relation with the possibility of not finding a workplace in the future if the young people do not have the required digital skills. So we have to think about designing software that could improve the digital skills of our small users, as you have seen, the preschoolers. So that is why we have discussed some things about designing for children. Then we discuss a little about our approach and the case study, and we draw conclusions and further work. As I have told you, in the European Union, there is a high interest in building a digital society, and our country ranks on the last position in the last years in terms of digital skills of its citizen. That is why we have considered that education should be the one that could improve the situation. And as in our country, in the primary school, there are ICT classes organized for the children that are attending the school. We have think about going to smaller level to the preschooler and trying to develop edutainment application that could help them build an attitude about technology that is different from the lifestyle digital skills that their parents has. That is why we have considered the new constraints that are brought by the age of our small children users, which cannot read, cannot write. Their main activity is playing. They cannot achieve adult stated tasks without being rewarded. They have a limited vocabulary and very basic interaction skills. Moreover, we want educational application. That is why we have considered edutainment application, which at the same time should deliver education and fun. So we have considered using a user-centered approach, but we need to keep the focus on our small users, which are not adult users that are usually encountered in user-centered design. So we have split the process in two steps, the development process and the validation process. And we have considered the adaptation of the software design process. And we call this step the adapted user-centered design, which consists in the steps of the user-centered design, which means user needs identification, alternative design, prototyping, and evaluation. And as you can see in this slide, the most important changes are related to the alternative design due to the fact that the alternative design uses sometimes abstract representation that cannot be understood or evaluated by the small children, which are preschoolers. That is why we also thought about evaluating the product that we developed with such small children. And we have considered that heuristic evaluation is the less expensive method that we could use. We had tried to find methods to use with such small users. And the only method that we have found was heuristic evaluation of children e-learning, which is designed for children from 6 to 10 years, but still there is a high difference between preschool children and school children. So again, we needed to adapt the heuristic evaluation approach, which consists in 3 elements or components, the Nielsen usability heuristics, children usability heuristics, and learning usability heuristics. And in this case, we needed to adapt more the part of learning usability heuristics, which often refer to the reading and writing capabilities of the children. So we have defined a method that uses the usual steps in user-centered design by involving the children in almost every step of the design, and also involving the educational experts, which are kindergarten teachers. There were steps where we have considered that we need more involvement from the parents of the preschoolers in order to gather the right information about their experience and attitude towards the software that we have developed. We have performed case studies on the method that we have proposed in building edutainment applications for middle group preschoolers, which in our country are 4 to 5 years children. We have applied the method using 26 teams of 3 to 5 computer science students attending the human-computer interaction lectures, and they were guided by 2 educational experts. As you may see, we have performed user needs identification by using field study in the kindergarten and getting used with our little users and understanding their capabilities and limitation. Then, as I have told you, in the alternative design, we have confronted with abstract representation, and in these steps, we have considered the intervention or the replacement of children in the design process with the kindergarten teacher, which were used as surrogate or proxy for our small users. There were situations when we could involve also the kindergarten teacher when the design team members were talented computer scientists. And also, we have evaluated the prototypes with the kindergarten teachers and also with the children. And we intended to gather their satisfaction by using a similar method to Smilometer, the Dragon methods, which are used in their usual activities in the kindergarten. Here you can see that children could choose from different emotional states like brave, happy, bored, or sad, which would represent their feelings or toward the experience of interaction. After going through this case studies, we have drawn some conclusion that it is very important that in the design process, the kindergarten teachers or the educational expert guide the entire process. Also, we have found that there are unpredictable situations where the children are performing actions in interaction that are not expected. They are quite unpredictable. Then on the content, usually the design team have overestimated the capabilities of the small children in terms of knowledge. And there is also the aspect of evaluating the software products that we have developed, because there are many aspects that have to be taken into consideration. The content that is presented, the educational output, and also the reaction of the children on the interaction. And we have considered that observation is a really important aspect that could provide us relevant information, and also parents are very helpful in finding out the impression of children on their experience. In terms of interaction design, there are a lot of challenges because of the lack of reading and writing capabilities of children. That is why we needed audio interaction with the children, and sometimes it was very difficult to synchronize the audio with the interaction with the children, which are hovering all over the screen. And also we had challenges in providing help to the children, knowing how long to wait or when to give support to the children. From the teaching of user-centered design, when the users are small children, the most challenging part was to introduce the students to the world of children, to organize all the visits and the interviews and the interaction with the little children, and also supporting the students in designing and evaluating the design products with the real children, with the real users. What we have done by now is to create a framework or a method from the software engineering point of view of designing edutainment application for preschoolers. We know now how to involve the children in the design process, and we know how to evaluate their satisfaction, but there are still things that need to be improved, like measuring the effectiveness of our approach and also measuring the digital skills improvement of the children. thank you. This is my presentation. I would be grateful to answer your question.
Thank you, Adriana. That was really exciting. So we have time for one question, and it's from Yaroslav. Thanks for the great talk. The constraints are very interesting. Could you elaborate on the possible ways of feedback collection from preschoolers themselves?
Sorry?
Do you want me to repeat the question?
Yes, please.
So the constraints are very interesting. Could you elaborate on the possible ways of feedback collection from preschoolers themselves?
Yes. As it is known, preschoolers or children are very willing to make the adults satisfied. That is why we have considered automatic evaluation of their emotions. We are working on a method to automatically gather their face, the emotions from their face, in order to objectively evaluate or assess their reaction to their experience.
Oh, awesome. Thank you.
We cannot use interviews.
Yeah, it's children, yes. Yeah. Thank you. And we are out of time. So with that concludes this session. Thank you all for joining in. I hope you enjoyed the talks. I would like to also thank all the presenters for all the interesting talks. And so please look for the presenters of this session in the lobby video chat, Slack, if you want to ask them more questions. And good morning, good night, good afternoon, depending on where you are. Thank you.
Bye.